Another video of Math Magic with Jen. Today we're going to be doing our second video on Unit 4, this one having to do with rates. We're going to focus on unit rates with notation and tables and all that good stuff. So let's check it out. What is a rate? Um, the simplest way to describe it is it's the quotient of two quantities. It's usually expressed first as a fraction, which includes units. Okay, meaning units of measurement, right? Are we talking about miles, dollars, hours, feet? So when I say units, I mean units of measurement. A unit rate is when we simplify the fraction by division. So you basically divide it out and you can get a whole number or a decimal. The most common unit rate that we use all the time is speed. So, the speed of a car. So obviously here we've got 40 miles per hour, and that means that that is obviously the speed limit here. But I want to point out that where this comes from, this idea of, well, first off, miles per hour is a rate. We're measuring miles for every hour we drive or fraction of an hour we drive. And here, if we were to take something like 80 miles and compare it to 2 hours, so this would be an example of a rate in fraction form. Okay. And then the idea here is that you actually divide 80 by 2. So taking a calculator, if the arithmetic is easy enough here, the arithmetic's pretty nice. I get 40, and then in just a second on the next slide, I'm going to explain how our units turn into miles per hour. So some of you may already know how that works, but the next slide, I'm going to go ahead and explain exactly how to change any units of measurement we're looking at. So hopefully it makes sense. Okay, so let's talk about the process first and we'll do some examples. Okay, so these are called, like I said, unit rates. If you're wondering why it's called a unit rate, when you do division, like back in the last problem when I had 40 miles per hour, the idea there is actually that we originally had 80 miles for every 2 hours. And the unit part is to basically turn it in so that the denominator is a 1. That's why it got the name unit, is because we want that denominator to be a 1. In reality, it's easier to do problems with straight up division, especially you're going to see some examples where calculators are the way to go. So typically we've just explained it to students that, hey, we want our rate to just divide it. So what's 80 divided by 2? I'm going to end up with 40. But it is basically showing a ratio, a reduced ratio of 40 miles to every 1. So that 1 in the denominator, which happens every single time you divide a problem, is how we got the name unit. Whether you find that interesting or not, there you go. I'm filling in the blanks. Okay. So here's how we do it. We're going to create a fraction using the two numbers along with their units of measure. Okay. Some people will leave the units of measure off until the second step, but I like to just go ahead, especially for students if that's their first time doing it. It's good to remember what these things are representing. We're going to divide the top number by the bottom. You can have your students do arithmetic, but I'll be honest, with a lot of sort of real world, more interesting applications, we use a calculator. Okay. So you're going to see some of the problems I do today. I'm going to do the arithmetic myself. It's easy enough. Others will use a calculator. Okay, now here comes the part that I said I was going to explain. How do you get the words to the side? Okay, so it's always your top word per the bottom word. However, the bottom word is always singular. So if we start off with hours, we're going to end up with hour. If we started with feet, we'd have foot. If we started off with miles in the denominator for whatever reason, we'd have mile. So you always want to make sure that that second unit of measurement is going to be singular. That's where students have trouble reading it. It just sounds funky, is if they have it still plural on the end. Because miles per hours sounds kind of weird. Okay, so let's go ahead and do a couple. Okay, so a writer, meaning like a novelist, can type 165 words in 3 minutes. Find the unit rate that the writer can type per minute. So we want to look at how many words per minute. So 165 words, and we want to look at it with 3 minutes. So that's our fraction. So that's our step one, is we create that fraction. Now we're going to do division. So again, up to you if you want your students to actually divide 165 by 3 as some arithmetic practice, or you're going to have them use a calculator. I think this one should be easy enough that I'm going to get 55. Okay, now let's practice what we write to the side. So the top word goes first, so words, per, and then we want this one singular. Minutes. Now, some kind of fun, interesting things you could teach your students. So, in a lot of rates, we'll replace the word per with a slash. So that's very popular in physics and chemistry and things like that. Okay. The other interesting thing is that some rates are so common they have abbreviations, like MPH is miles per hour. Well, there's actually WPM for words per minute. So, some temp agencies and things like that will actually still test you to see how fast you can type for placement for certain types of work. Okay. All right, let's do a second example. A truck can travel 90 miles on 4 gallons of gas. Find the unit rate of the distance the truck can go per gallon of gas. So we're going to go 90 miles and 4 gallons. Now, somebody might write gallons of gas, and that's fair, but I'm just going to write gallons. So there we go. And for this one, I'm going to cheat and use a calculator. So 90 divided by 4 is 22.5. So yes, you can get whole numbers or decimals as our answer. And here, let's practice again, writing those units. It'd be miles per, and then I want the singular of gallons, and I get gallon. Again, this one is known as gas mileage, and those are called MPG. So you could decide for yourself if you want to teach your students different little acronyms that are common, or if you just want to stick to miles per gallon. That's up to you. Okay. We can also do some rate comparisons. So here we have Tyler and Shannon are both reading Harry Potter and the Goblet of Fire, one of my favorites, book 4. Tyler has read 200 pages over 4 days. All right. Shannon is over 3 days. Which student is reading at a faster? Okay, this is interesting because some students may focus on, yeah, but Tyler read more pages. And high five to Tyler, very proud that he read more pages. But if we were looking at like reading speed, okay, not that it's important for students to read fast or slow, but it might be interesting just to know, looking at these two, who appears to be reading at a faster rate. Okay, so over here, we're going to go 200 pages and we're going to divide it by 4 days. And 200 divided by 4, I'm pretty sure I can do that one. That's going to be 50 pages per day. Okay, so that's Tyler's, right? Go, Tyler. And then Shannon is reading 180 pages over 3 days. And I think that's going to be 60 pages per day. Awesome. So they're both doing fantastic. Hope they're enjoying those books, but technically one is reading faster. So faster would be whoever is reading more. Okay. So here that would be Shannon's got 60 pages per day. So I misspoke just a little bit. I said that faster is who's reading more per day. I didn't finish that statement. So faster would be whichever one has a faster rate between the 50 and the 60. So Shannon is currently reading at a faster rate, but shout out to Tyler, who's read more of the book so far. Okay, at least according to this. All right. Well, we've got some interesting examples from the textbook. I had to kind of read some of them a couple times because it just seemed kind of funky. Here's a classic example of one that's a little funky. So it says Elijah and Sean are participating in a walkathon. Each student wants to calculate how much money he would make from his sponsors at different points of the walkathon. Use the information in the tables below to determine which student would earn more money if they both walk the same distance. How much more money would that student earn per mile? Okay, so if you've participated in walkathons, readathons, eating-a-thons, whatever it is, usually students get sponsored. It could be either a flat rate or per lap, per, slice of pizza or per page that they read. And so what's happened is Elijah and Sean have gone out and got sponsors. Okay. So the idea is that we're going to assume that they're going to do the same amount, meaning if one person walks 5 miles, then the other person's going to walk 5 miles. If the other person's going to walk 10 miles, then this one's going to walk 10 miles. So the idea is that if we assume that they're walking the same distance, we're basically trying to find out who's being sponsored more per mile. And this comes to my next thing. Who is walking this many miles? Is this in a day, a week, a month, a year? So I really kind of question some of these problems. Why don't we just call it laps? So I got to change that. I'm sorry, because it thinking of some kid walking 28 miles kind of is beyond me. I know that we could be looking at a large span of time, but are you with me? It's a little strange. Okay, here's what I do like about this problem, though. So let me get to what I do like. I do like that we're going to calculate their rate based on a table. And you'll notice that the bigger numbers below and the smaller numbers above. So we're also going to flip it. So what we're going to do is if I want to calculate Elijah's rate, I'm going to take 35 and divide it by 7. And here's another thing I like about this problem. If we had a table group working on this problem, we could assign each person in the table group a different fraction to calculate. And what should happen is that all of these are going to equal the same unit rate. Whether I look at 35 to 7, 70 divided by 14, 105 by 21, all these are going to give us the same value. And by the way, that value is 5. Okay, so all of these are going to divide out to the number 5. Now, if you noticed, this bottom number is now the top, and this is dollars. And the number 7 is referring to, I changed it to laps because I didn't want to kill these students. Okay, so what's happening is Elijah's being sponsored $5 per lap. Okay, excellent. Well, let's go see what's going on with Sean. So here again, we're going to flip them. We're going to put the 33 on top and the 6 on bottom. And again, if I had a table group, I might assign each student a different fraction to calculate here. And what should happen is I should get the same number between all of them. And this one ends up being 5.5. So here we've got, again, this is dollars on top and laps on the bottom. Sean is making $5.50 per. So they walk the same amount. Sean is being sponsored more per lap, and he's making 50 cents more per lap. So Sean is making 50 cents more per lap. Cool. All right. I know I've got two more examples to show you, so hopefully your brains are still with me. Each one's a little different because I want to focus on some different cool aspects that you could do in your own classroom. Okay, unit price, one of my favorites. So everybody's looking for a deal, right? What's the best deal at the grocery store when you're shopping for items? And so the big thing you need to stress here is that what we're trying to figure out is what is the cheaper price per item, but technically one could cost more overall. For example, if we went to go by the scenario where package A of dinner rolls sells for $2.99 for 8 rolls, and package B sells for $3.89 for 12 rolls. Well, maybe I'm on a budget and I want to buy that $2.99 no matter what. Even if it's not the better buy, maybe I'm like, I only want to spend $3 for these dinner rolls. Fair. But if we didn't care if we bought 8 rolls or 12 and we are just interested in which one is cheaper per roll, here's how it works. And you definitely want a calculator for this. So we take a calculator and we're going to divide $2.99 by 8. And what you're going to get is, it's going to go on for a while, but it's basically 0.37 or 37 cents per roll. So we could write it this way, or when you write it this way, this is the same thing as 37 cents per roll. So that's package A. Package B is $3.89 that I'm going to divide by 12. And I end up getting 0.32, which is 32 cents per roll. Okay. So assuming we didn't care if we spent $3 or $4 total, and instead we were curious about which one was cheaper per roll, then that's package B. Package B is technically the better buy of only paying 32 cents for every dinner roll. Now, let me tell you some cool stuff about this. You can look at ads online or have your students go to grocery stores. You can also create your own little kind of shopping list that you have found. So maybe you're looking at, hey, a box of Capri Sun costs this much and there are 10 bags. How much is it per pouch? Whatever it is, you can get your students interested. Also, you can teach your students that at most grocery stores, on the shelf where you see the $2.99 and the little code, the barcode that's there, off to the side in the corner, it'll actually say the unit price. It'll be really small and it'll say unit price. And so for this $2.99 package of rolls, it would actually say 37 to the side is the unit price. It does it for everything. You can look at it for cans of soup, where it'll do it per ounce. Boxes of mac and cheese, you name it. It'll actually, I think boxes of mac and cheese, would it do it? They might do it per ounce. That's a good question. I may be lying there. But I do know that for soup, it will tell you per ounce because I have looked before at if you buy the 15-ounce can versus the 32-ounce can, and kind of fun to kind of look at those values and see if they stay the same, if they go higher, if they go lower. It's just kind of an interesting thing to look at. Okay. And now you think I'm crazy, but whatever. That's the price I pay. Okay, my last example for rates is an hourly wage. Yes, hourly wages are a rate, how much you get paid per hour. Now, I will say, when I was looking at the Common Core textbook examples, a lot of their wages was like $7 per hour. And, it was a little low. I live here in the state of California, and I think our minimum hourly wage is now like $16 per hour or something like that. So I tried to make up my own example that would use numbers more in line to where I live. Okay. But you can decide if you just want to use the book, if you want to make up your own values. Um, are they not actually at a typical job, but instead maybe they're mowing lawns? How much are they making per hour? You could do it any way you wanted, okay? For my example here, it says Brandon and Alicia both work at different ice cream parlors after school. Brandon is paid $240. So good old Brandon's got $240 over 15 hours of work. Okay. So if we divide this, we're going to find out Brandon's hourly wage. So 240 divided by 15, you're going to end up with $16 for every hour. Alicia's making $315 for every 18 hours. Okay, so let's see what 315 looks like divided by 18, which is 17.5. Okay. So this asks the question, do Brandon and Alicia make the same per hour? And no, they don't. No, they don't. And no judgment here. There could be reasons why Alicia's making more. Maybe she's got more experience. Maybe she is doing some extra duties that Brandon's not. Or maybe there's no reason at all. But I'm just saying, here we can look to see how much each person is making per hour. Okay. Awesome. I hope you found this unit interesting. No pun intended. You can do a lot with unit rates. I definitely encourage you to search online, see what other resources and worksheets other people have created. There's a lot of cool stuff out there. This is just the tip of the iceberg, so to speak. So go out and have some fun and hopefully enjoy finding unit rates. Until next time, have a wonderful rest of your day and keep doing math and staying positive. Bye bye.